All right, today's problem, split array, largest sum, difficulty is hard. Accuracy is really high for a hard problem, almost 60%. Given an array and an integer, k, divide the array into k contiguous subarrays such that the maximum sum among these subarrays is minimized. Minimize the maximum sum. Okay, find this minimum possible maximum sum. Probably needs an explanation. I wish the examples here were a little bit more, a little bit less trivial, but okay, so let's say we have this as an array. We have k equals 3. We need to split that into 3 subarrays, and the optimal split, as it turns out, is, let's see, the 1, 2. Which is, let's see. So the sum is 3, and then 3. The sum is 3. 4. The sum is 4. Maximum sum is 4. So that is the minimum possible split. Is there any other way to split this? Not really. I mean, the absolute minimum that you could get out of it is 4. As a single array. If you added anything else to the array with the 4, and they have to be contiguous. So if you would have to have 4 and 3, and then you have 7. Now it's too much. Combine the 2 and the 3, you're going to get a 5. So no, you can't do it. This one is that one I don't think is really worth looking at. It's just too trivial. Array size can be somewhere between I'm sorry, wait. Okay, so, array size can be somewhere between 1, well, let's say it this way. Both k and the array size can be somewhere between 1 and 10 to the 5th, inclusive. 10 to the 5th, 100 is 100,000. Each array element will be somewhere between 1 and 10 to the 4th, 10,000. Expected complexity, n times log of the sum being if you added up all the array elements. Google likes this question, and the topic tags, other than the obvious one, would be binary search. All right, so it seems like binary search is the key to this. We see binary search here. We see the expected complexities is n times a log, which suggests a binary search. All right. Well, let's scoot this over here and see how we might do this. This actually is similar to another problem of the day. I can't remember which one, though. But without overcomplicating it at the beginning, like, well, how many arrays are we supposed to split it into, etc., etc. Just taking any array, the range of possible minimum. Well, wait a minute. the range of possible how do I want to say this? The lower bound on the minimum maximum sum would be, the lower bound would be the largest element in the array, as we saw in this 1, 2, 3, 4 example. And actually, let's use the 1, 2, 3, 4 example. Can I slide this over a little bit so we can see the 1, 2, 3, 4? Okay, 1, 2, 3, 4. So the minimum, let's call it, I don't know. Wait a minute, I need a pen. The minimum, let's call it Yeah, let's call it min. All right, let's call it min. Would be 4. And the maximum would be the sum of everything in the array, because we don't know what k is. So maybe k is 1. It could be, that's within the constraints. So the max would be just the sum of all of the elements. In this case is 10. Okay. We have a result that we want to get to. Let's initialize that to the highest possible value. So if nothing changes, we'll just return that. All right, so now we do the binary search. All right, so we'll figure out what mid is. Mid is, in this case, 4 and 10. 1, 2, 3, 1, 2, 3. The mid would be 7. It would be 7. All right. Now we need a helper function. All right. We want to get the number of groups that we would need to split this into to get a result of 7. Okay, so let's go down here and start working on the helper function. Wait a second. Input to the helper function will be the array and the result that we're trying to get, 7. All right, now down here, we're going to have number of arrays. I guess they really would be called subarrays, but arrays, and we're going to have to start with 1. Okay. We are going to need a sum, and initially that is going to be 0. All right. Now we'll go through all the numbers in the array. First number is 1. So let's look at current sum plus 1. Is that greater than the max sum? And actually, we should put that down here because that does get passed into the array. So the max sum, what we're trying to do here, using a binary search over the range of possible results to find the minimum. All right, so in this case, we're trying to find 7. How many arrays, how many subarrays do we need to achieve a maximum of 7? Is it within the range of, what is our range here? 3. Is it within the range of 3? All right. So if the current sum plus the number 1, is that greater than max sum? And it is not. So current sum can be, we will increment that to 1. And in fact, what we would be doing here is creating subarrays with, that would include a 1. Now we go to the next number. The next number is 2. Is 2 plus the current sum of 1 greater than max sum? And it isn't. So we've got 3 there. Okay? So let's add that to a subarray. Next number is 3. 3. If we add that to the sum, is it greater than the max sum? No, it's not. So we got 6. We have, and we can add a 3 there. What about the next number, 4? If we add it to sum, is it greater than the max sum? Yes, it is. So in that case, we need to start a new array. Okay, 2. The current sum would be the current number, which is 4. And so essentially we would start a new array with the number 4. Okay. We've gone through all the numbers. We return the number of arrays that we need to get a maximum of 7. The number of arrays that we need is 2, and that is less than 3. So because of that, it means that we can possibly get an answer that's better than 7. All right? So we could try to find a smaller largest sum. So the result, let's change it to 7, because we know we can get 7. But maybe we can do better. So we're going to change this to mid minus 1. Okay, so 6. We're going to try and do it again. Let me erase these. I'm going to try to do it again. Okay, so what comes in here? Arrays is initialized. Initially 1, sum is 0, and max, this time we're going to see, we need a new mid. Mid of 4 and 6 is going to be 5. Can we get a max of 5? Well, let's try it. 5. All right. So we go through the numbers. Is 0 plus 1 greater than 5? It's not. So change that to 1, and in the first array, we'll put a 1. Next number is 2. Is 2 plus the sum greater than 5? No. We'll put a 2. Okay. Is 3 plus the sum greater than 5? Actually, it's not. It's equal to 5. So we can put that in. Oh, no. I'm sorry. 1 plus 2 is not 2. 1 plus 2 is 3. Is 3 plus 3 greater than 5? Yes. All right, so we're done here. We can't put a 3 in there. So we start the next array, 3. We increment the number of arrays. All right, next number, 4. Is 4 plus current sum greater than 5? Yes. All right. So we can't go any further with this. We're going to need a new array, 4. Okay. Let's see, what else? Number of subarrays, we have to increment that. We now have 3. And then we'll return it. We'll return the number of arrays. We have 3. Is that less than or equal to the number of arrays that we're allowed to have? Yes, it is. So 5 is actually a possible result here. That 5. All right. But maybe we can do better. Maybe we can do better. So we create a new midpoint. Let's see. I'm sorry. No. Maybe we can do better. So we got to try to get a better midpoint. So we set max to mid minus 1, which is 4, and then the midpoint would be 4. Can we, in fact, get a result of 4? Okay, so we clear out our helper function here. Start over again. So now we're trying to get a max of 4. We'll initialize the number of arrays to 1. We'll initialize the sum to 0. And iterate through the numbers. First number is 1. Is 1 plus 0 greater than 4? It's not. So we can add that, and that is going to go in the first array here. Next number is 2. Is 2 plus 1 greater than 4? No. We can put a 2 in there. Okay. Next number is 3. Is 3 plus 3 greater than 4? Yes. So we're going to need a new array. Need a new array. The current sum will be the current number, which is actually 3. And so we'll start the new array, 3. Okay, we go to the next number. Next number is 4. Is 4 plus 3 greater than 4? Yes, it is. So what that means is we need a new array, and we will add 4 to the new array. Okay, we're done. We went through all the numbers. We returned the number of arrays, which is 3. Is that within the approved tolerance? K equals 3? Yes, it is. So what happens is result will be changed to mid because we can achieve a 4. Okay? Maybe we can do better. So we change the max. Max equals mid minus 1. Well, now we've crossed over. The max is now less than the min, and that means our binary search is done. And our result is 4. So that's the basic idea. We create a range of possible results. The range would be the maximum single value in the array. Did I say the max? The min would be the maximum single value in the array. The max would be the sum of all the elements in the array. And then we just do a binary search and we try it out using this helper function. Can we achieve that number? If we can, then we try it. So maybe we can get a lower number. If we can't, then we've got to try to get a higher number. So that's how the binary search works. Anyway, let's put some code in here and see what happens. Okay, quick walk through this. We have a start and end. Actually, the example I was calling it min and max, but start would be the max element in the array. And, min, and max would be the sum of every element in the array. We can initialize our answer to end because that's as high as it can get, and we're going to try and make it lower. Here's our binary search. We get the mid. We call the mid groups function, which we went through. The mid groups function returns how many subarrays do we need to get to the answer that we've selected. Now, it was not true in the example, but it is possible that we can get that result, but we need more than the allowed number of subarrays. In which case, you can see that here. In which case, we need a bigger number. We can't get a number that low. So we'll adjust the binary search. If we can get that number, then we'll save that number and we'll try to get an even better number. And that is the idea. Let's run it and see what happens. Okay. Good. Geek bit. So what is the key? What is the key here? I mean, the key is to come up with a range of possible results for the problem, use binary search to test them. We can test them pretty efficiently that way. Again, the runtimes n times the log of the sum, and that's it. So, like the video, subscribe. You will get problem of the day in your inbox. Every day, every weekday. And that's it. We'll see you next time.